Well, hello there, and welcome to this little video on subnetting. And we're going to kind of get you introduced to the math and science behind subnetting and what exactly it is. So, this is kind of a topic covered in a weekly subject I cover with IEEE and DeVry University. Um, if you are a student of DeVry University, please look for the DeVry um, IEEE Student Chapter Discord server. Uh, every week we're trying to do a live ask the professional session where you can come on and you can ask me like anything you have related to electrical engineering, networking, programming, all kinds of topics, including even database analytics. This video here we're going to cover subnetting. So basically, let's go ahead and build us a quick network here. We got a little cloud, so this is going to be our World Wide Web. We'll just call it www, so World Wide Web. Next up, we're going to go ahead and create our basic network structure consisting of a router and let me see if I can find my basic switch symbol I always like to use. Where is it at? Switch I like to use is usually two ways here. I'll switch. Programmable switch. I mean, we could go with that. So basically, what we're targeting is subnets and kind of how you can address them. So let's say we have a basic house network here being, we have our World Wide Web connection coming in. I wonder if I could change that to a two-way communication here because, of course, if you know networking, it goes both ways. Yeah, like that. So we have basic World Wide Web to our router / modem, and then we go out to our switches. Okay, simple house network setup here. We're going to say that our house router here is going to be an address of 192.168.1.1. Or I'm sorry, 1.1 is our router's address. Okay, so this is our router, and then we have a switch here, which honestly switches don't really rely on an IP address truly. Unless they are a layer 3 switch. So usually switches, you don't really give them an IP address. So we'll skip over that. Let's add us a few computers here. So we'll have PC1, PC2. We'll probably add some laptops in as well. And this is going to kind of form our little network we have. I don't know. Do I have a wireless router in here at all? Possibly. I don't know if I have a wireless router. I haven't really examined these shapes that well. But okay, we'll just say here's our basic network structure. We're going to say that the two computers here are connected to our switch. Meanwhile, our laptop over here is going to be a wireless device. I don't know if I have a symbol in here for wireless. We'll probably say wireless is these dashes. How about that? So here's our wireless connection into our switch / house router. Okay, so we have a wireless connection and we have two network connections. Let's also add in, if we can, a printer of sorts somewhere. If I can find a printer icon. Yeah, here's a printer. And we have a printer that's also connected to the network. All right, so for our little network structure here we want to make it to where not all devices are immediately talking with each other, okay? We want to add some security features because say I'm working at a school, okay? We have our staff laptops, we have our computer lab, we have our front desk administration, then we have our printers and other network devices like smart devices and stuff like that. Problem is we do not want all these devices always communicating to each other. So how do we actually achieve that? How do we, if we only have so many IP addresses, how do we make it to where all these devices are not immediately able to talk to each other? Well, that's kind of where subnetting comes in. Now, subnetting is really important in the Internet of Things because we are limited to only so many IP addresses in our world. Generally, an IP address can be anything from 4 zeros all the way up to 255, 255, 255, 255. Okay. So that's kind of our IP range. And if you do the math on it, if I open up a calculator here, I actually have one open already. We have 32 possible bits in an IPv4. So what we'll do is we're going to see how many possible IP addresses we really have in our world. So 2 to the power of 32, and that equals that many IP addresses available in our world. We only have 4,294,967,296, and that is ranging from zeros, so 4 zeros, all the way up to 255, 255, 255, 255. Okay. So honestly, this is this big range. It didn't always exist. There used to be what was called classful IP addresses, and classful IP addresses ranged from A to F. And this was in the beginning. All right, so this is the very early stages. Subnetting was not created at the time, but now we have what's called subnetting, and it makes it to where that number of devices can be multiplied by itself. Okay, so we have this many IP addresses available to us. Well, we could take that squared. Okay, so that to the power of 2. That's how many possible devices we can have in our world today, if we do appropriate subnetting. So if all subnets were used and all IP addresses were used, this is how many possible IP addresses we could have. I believe I might be wrong on that math, but aside the point here. So let's look at our network diagram here. We have just basic house setup here, but we're going to say this is a school setup. Okay. We have a router into a switch, and then that switch distributes to all our devices. Now we have our computer lab here. So we'll call this computer lab. We have our administrators. Okay, so front desk, so administration offices. Then we have our staff computers. And then we have printers and everything else. Well, we'll call this actually wireless computers. How about that? Wireless computers. Wireless computers. Okay. So the thing is I do want all these devices to kind of communicate in the end, but we're not getting into that topic, which is called trunking. We're going to be only focusing on how can we make it to where all these devices are on separate networks so that we have more security structure in place and we have more flexibility to distribute. So the first math I kind of showed you with the 2 to the power of 32, that kind of relates to our World Wide Web. Our World Wide Web will provide us an IP address that is called our public IP address, usually provided by our ISPs or internet service providers. We're not looking at that. We're only looking at the internal network. So on the inside, our router has that public IP address, but inside our router for our internal network starts at this IP address. And our subnet that we have available for us is going to be 255.255.255.0. Okay, typical house subnet, which is a subnet mask of 24 bits. Okay, so you could say this is a 1.1/24. Okay, now I want to create 4 different networks. I want my computer lab, I want my front desk, I want my printers on their own network, and then I want all my wireless devices on their own network. Okay, So what we could do is we could take the /24 network and we could figure out, okay, how many, if I want every network to be the same, I want them all to have the same number of devices. What do I have to do? Okay. Well, what we need to do is we need to think, okay, how many subnets can we get by borrowing bits? So if you don't understand subnet masks, they are a binary translation. Okay, so what we see 255.255.255.0, that actually equates to 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have this is actually equal to this. Okay, so 8 ones equals 255. 8 zeros equals 0. Now, to be able to calculate our devices that we could have in our network and our subnet masks and our network addresses and our broadcast addresses, we need to first think, okay, how many bits do we have to borrow out of here to create our subnet mask that we need? The answer is we need to borrow 2 of these bits and make these 2 bits be reserved to where they can't be changed in each network. Okay, so what we have to do is we have to first calculate with 2 ones here. So we're going to change this. We're going to make a new subnet mask being with borrowing 2 ones. So we're going to convert this. Let's copy this area here. We're copying it over here. Now over here, we're going to change this value to a 1, 1. Now, why is it 1, 1? Okay, well, here's what you can do. To figure out how many possible subnets you can create, we got to think, what is our main mask? Okay, so our main mask is all these, so we can now borrow these zeros and turn them into subnets. Now, to figure out the number of subnets we need, we have to do some math here, which is 2 to the power of x, okay? So 2 to the power of x. Let's say I want 4 subnets, okay? Well, 2 to the power of 2 is 4, okay? That's where we get these 2 ones. But say I want to have 8, okay? I want to have 8 subnets, or I want to have 8 subnets in my network, okay? Well, that's where we go 2 to the power of 3, okay? So if we took one more of these ones, we'd have 2 to the power of 3, okay? You see where that's going? 2 to the power of 3, all right? And that would, if I pull up the calculator again, so 2 to the power of 3 equals 8, okay? So that's how we get 8 possible subnets. Well, we only want 4 subnets. So again, 2 to the power of 2 equals 4. I'll sample that here for you. 2 to the power of 2 equals 4. Okay. So we have 4 subnets. Now we also have to translate our mask because honestly, in a subnet mask environment, if you open up your network manager by typing window R ncpa.cpl and we go choose one of my adapters here and go to properties and then IPv4 properties, you will see that we can't put all these ones. Like I could try putting in 1, 2, 3, 4. It always limits me to 3. So we have to we have to make a subnet mask appear here. Okay. So that calculation, if we're borrowing these 2 ones to create 4 subnets, we have to take 128 plus 64. Okay. Now, where's that 128 plus 64 coming from? Well, that 128 plus 64 comes from how binary numbers work. All right. Binary numbers follow this standard here. Okay. So it goes 128, 64, 32, 16, 8, 4, 2, 1. Okay. So bit 1 is equal to 128. So this 1 is 128. Then we have 64. Then we have 32. then we have 16, 8, 4, 2, 1. All right. So if we are borrowing the first 2 bits in this last subnet, what we have to do is we have to take bit 1 plus bit 2. All right. So our math would be 128 plus 64. So calculator again. You probably already know the answer, but I'm just trying to sample here. 128 plus 64 equals 192. So our subnet mask up here should be translated to 192. All right. So here is our binary math here. We've converted this into 192 and we get 4 subnets. Next up, we have to think, okay, well, what's the possible count of devices that will be on each one of these subnets? And the answer is, how many zeros do we have? So we have 1, 2, 3, 4, 5, 6. So the math equation here is we have to take those, we take 2 and we go to the power of 1, 2, 3, 4, 5, 6 zeros. Okay, so 2 to the power of 6. And that will equal 64. Okay, so we have 64 possible IP addresses in our network. All right, so every one of these subnets, if we gave every subnet the subnet mask of 192, we will have a total of 64 possible addresses that can be distributed to our different networks. But here's the next problem. In networking, you have what is called a network address and a broadcast address, okay? So the network address and broadcast address, it starts at like say 0 all the way up to 255 if we were doing a /24 network. Okay, so do you ever notice how in your house network you can never put your IP address at the 192.168.1.0? You can never assign an IP address that, unless if you're in a different type of network, but we're not covering that today. In the matter of a I'm sorry. Yeah, you can't have that dot 0. But then also you also notice that in your house network, you can't have an IP address that ends in 255 if you're doing the typical 255.255.255.0. Why is that? Because the last IP address in a network is what is called a broadcast address. And the way a broadcast address works is, say my wireless computer is trying to call out to this printer here. Problem is, my wireless computer doesn't know what its IP, what the like the exact route or who exactly carries that IP address. All right. So what happens is like computers in the network, they're going to communicate through a MAC address. So what's going to happen is my computer is going to call out on the network by calling out on that channel of 255 or whatever the last IP address is in the network. And it's going to say, hey, who carries the IP address of 192.168.1.10? Okay, so what's going to happen is we send a packet out into our network. It goes to the switch. The switch now is going to look through its IP pool, and it's going to say, okay, do I know of anyone with a MAC address who has an IP address of 192.168.1.10? Well, if the switch says, oh, I don't know anyone by that IP address, so what's going to happen is the switch is now going to send a packet to all of the devices connected to it. It'll say, I'm sending to you, I'm sending to you, and I'm sending to you. It's going to say, hey, everyone, which one of you carries this IP address? Well, Mr. Printer here, who is our 1.10 IP address, he's going to reply back saying, oh, that's me. This is my MAC address that you use. Okay, and then this will come back to our wireless device, and it's going to say, hey, the MAC address you're trying to communicate to is 25 1A 23 FF 2F 3D. Okay, that's made up MAC address. If you notice, I'm kind of struggling guessing, but that is what a MAC address is structured like. It's usually hexadecimal, which the numbers in hexadecimal range from 0 to F. And that's because there's 15 characters per hexadecimal character. And a hexadecimal is actually translated by in the same as binary. Okay. Except hexadecimal only counts the first 4 or the last 4. We're not getting into that math today. That's more for IPv6 networking. We want to focus on the IPv4 networking. But anyway, so that's that. That MAC address gets sent back to my computer. Now my computer will constantly send its packets straight to that MAC address. And if any of these other devices ask for that same IP address, the switch now has that MAC address tied to that IP address. So if someone calls out for that IP address, it'll say like, well, that should be this printer here. And is it connected? Yes, the printer's connected. So let me send you back saying, here is the MAC address of the device you're trying to call out for. So rather than having to broadcast across the entire system, it'll stop at the switch. So that's kind of your basic fundamentals there on how that part works. Well, that was how broadcast networks work. Our problem here in making our new networks, to divide them all into 4 different networks using the subnet mask, we now have to figure out what is the network address and what is the broadcast address. Okay. Honestly, it's simple if you're going with a structure of always doing the same IP like this. Okay. If you're going to have all 4 subnets being the same, it's really simple. All you have to remember is that 2 to the power of 6, which is 64. And what you're going to do is you're going to go to your starting IP address, which was 192.168.1.0. We're going to add 64 to it, okay? So 1.0 plus 64, that becomes 1.64. Now, that's not the broadcast address, all right? Your broadcast address will be that total minus 1. So if you want to find the broadcast address of the network, we're going to say, okay, our network address is .0. Our broadcast is the total number of possible IPs minus 1. Okay? So in that case, 63. Because you got to remember that first IP address is part of that 64. So that 0 is part of that 64 structure. So 0 is actually number 1. So 0 to 63. That's 64 IP addresses. Okay? 0 is your broadcast. I'm sorry, 0 is your network. 63 is your broadcast. All right? So that's kind of how that structure works. So we want to start communicating to our devices here. So we already came up with the fact that, okay, our first network is going to be 192.168.1.0. All right, and that's kind of just going to be our prime network that has no interruption. It can communicate to our switches. Honestly, you kind of want this to be your intermediaries. In fact, we're going to say that this is our intermediary devices. And if you don't know what intermediary devices are, that is your routers, your switches, your firewalls, all that stuff. And honestly, you don't want people really being able to just go connect straight into them and be able to change all their settings. You don't want people just immediately having that type of access. So all my network devices will say that they're on a network, and these 2 devices are on another subnet. Okay, so this is our network address right now. Let's add our broadcast address. And again, I told you 192.168.1.0 plus 64. But do 64 minus 3. It's easier. Okay? 64 minus 3. I'm sorry, minus 1. 64 minus 1. So that equals 63. So 0 plus 63, we have a total of 63. Okay? Now, if we want to just know only our network addresses and we're wanting to ignore the broadcast addresses, all we have to do is add that 64. So if I just want to look at only my broadcast addresses, I just have to add 64 every time. So we have 64. So this is going to be our network address table here. So we have .64, then we have 192.168.1.64 plus 64, which is 128. Okay, and then finally, our last network address, 192.168.1.128 plus 64. So 128 plus 64. Okay, 192. That's our final IP address. All right, or our final network address. 192. All right, so these are our network addresses. When we want to find the broadcast addresses, except for the last one, you just have to take whatever the next network address is minus 1. So for this one, it's going to be 63. For this one, it's going to be at 127. For this one, it's going to end at 191. And then for this one, it's going to end at 255. All right. So let's say my first network here is my intermediaries. So there's a shape tool here somewhere. Let me see, basic shapes. We're going to just take a basic shape here. And, oh, these aren't clear. All right, I'll just have to hollow it out. We'll take our basic shape here. We're going to say this is our intermediary devices. So I'll go ahead and highlight these and figure out how we can do a fill. No fill. All right, so we have our basic intermediaries. Okay, so that's our first network, and that's going to be our 1.0. So for that network, we have 192.168.1.0 dash 192.168.1.63, and this has the subnet mask of 192.1, or I'm sorry, not that. It's subnet mask of 255.255.255.0. Okay, so that's your basic IP. That's your IP address range. So all my intermediary devices, they'll be addressed .0 through .63. Okay, or I'm sorry, .1 through .62. Okay, 1 through 62. Those are the devices I can use. All my devices in the middle, 192.168.1.1, all the way up to 192.168.1.62. Our next network here, we're gonna put it on these two computers here. So I'm gonna just copy this shape and we're gonna put it over here. All right, so we have our computer lab and our front desk. We're just gonna call these our wired devices. Honestly, I would put if I'm in a bigger professional environment, I'm gonna put these on two separate networks. In this case, we're only putting them on one. So again, we start out at 64, and then our network address ends at 127. And then I also just noticed I kind of made a little boo-boo here. There is, I said 255.255.0. It's the 192 because this is our subnet division here. Same down here. This is going to be .192. All right. We'll copy this shape here. We're going to paste it over here. Now we're going to focus on our printer network. So our printer network, all the devices in the printers network, is going to be, put this up here in a way. Might as well just stretch it. Might as well just stretch this out some more just so we can see it. Our printer network here is going to now start at 128. And it's going to range all the way up to 191. All right. And again, it still has that 192 mask. Finally, we have our last device up here. And that's going to be Control-C, Control-V here. That one will be ranging. Let's try dragging this back down some here. This one, just like the printer network in a way and the other networks, this one will range from the 192 all the way up to the 255. All right. So network address is 192, broadcast address 255. Network address 128, broadcast address 191. Okay. Now, I'm sure you're also wondering here, well, could I go a little deeper? Say I don't need, I only have like 20 some devices on my front desk network, and I never plan to change it. I only have 20 some devices in my computer lab, and I don't plan to change it. Well, you could take subnetting a step further if you wish, okay? And that's where we're going to look at borrowing another one of these bits, okay? So we're going to do another subnet mask here, okay? Let's say I want to split these two devices, put them on two separate networks, okay? I don't want them both being on this one network. So what I could do is I could actually take that subnet mask, break it down the middle into two separate subnet masks. And how do we do that? Well, we just got to add another one to our binary bits. So we'll add another one in here. So we'll copy these two values here. And we're going to come up with our new subnet mask. And this is going to be the subnet mask that will be used on these two networks when we break those into another subnet. So I'm going to put another one here. Now we have to pull up my notepad again here. So we have the first 3 bits turned on. So we have to get the sum of 128 plus 64 plus 32. We already know that it's the sum of the first two adds up to 192, as we saw here. So we just have to add that other 32. So let's take 192 plus 32. Whoops, not plus 32. That's going to equal 224. Okay, so our new subnet mask for our other devices here is going to be 224. All right. So what we'll go over here and do, we're going to break these into two separate networks now. All right, so we have subnetwork 1, and I'll drag this one up some for that. And then we have our subnetwork number 2 down here. Okay, so now these two networks are going to be subnetted from each other. So what we have to do here is we're going to take our subnet mask of 224. Let's go ahead and change this value here to 224. Change this value down here to 224. All right. And then we now have to figure out, okay, so our IP address range between these two networks was 164 all the way up to 127. Now we're kind of breaking it down the middle. So to figure out our broadcast address of this network, since it's our lower network, what we have to do is we have to take the 5 bits here that still remain. So 1, 2, 3, 4, 5. Those are our borrowed bits. And we're going to go ahead and do 2 to the power of 5. That equals 32. So we have a total of 32 possible IP addresses in this range. All right. So we'll take 64 and we're going to add 32 to that. Okay. So clear this out. Let's do 64 plus 32. That's going to equal 96. Okay. So 96 is our next IP address, our next network. So see that again, 96. So that's the starting of this network. If we subtract 1 from that, we're going to get our broadcast for up here. So 96 minus 1 is 95. So now we have our 2 separate subnets here. This used to be one whole network, but we decided we're going to break it into 2 by just making a whole nother subnet. And now our subnet ranges from 164 to 195, with 64 being our network address and 95 being our broadcast address. Anything in the middle between those can be sent out to devices. So that should pretty much make some sense for you in the basics of subnetting. Now, a big question you might have is, okay, well, how deep could I go? How big can my subnet mask be? Can I really make it be a 255.255.255.255? Answer is no. Okay, because you have to have that broadcast and you have to have that network address. All right. So if we can't borrow any bits, then there is no network, period. So the lowest you can get is a /30 network. And a /30 network is where you have 255, 255, 255, and then we're going to borrow 6 of the 8 bits. Okay. So your lowest network you can get to, which is usually used between 2 routers. So when a router and a router are talking, usually You have your house router, and then you have your ISP router, okay? So when these two devices are talking, they're usually communicating through a /30 network, all right? So let's change our number here to 3 more ones, okay? So we have a total of 6 ones. And now to calculate our subnet mask, if you followed along, you should know how to do this by now. You're going to do how many ones we have. So 2 to the power of the count of ones, which is 6. So 2 to the power of 6. That's going to equal 64. Oh, I'm sorry. That's how many possible subnet masks, or how many subnets we could get. Let me rephrase that. To figure out our subnet mask, we have to actually take we take our max number, which is 255. We're going to subtract, and in parentheses, we're going to do that little math equation we just did, which was 2 to the power of 6. All right? All right, so 255 minus 2 to the power of 6. Our value is 191. All right? That's not right. Hold on. 224. Oh, I'm sorry. 255 minus, it's 256, actually. 256 minus 2 to the power of how many bits we have. All right? Let me clear that out. So 256 minus 2 to the power of 2. All right? So we have 2 bits that are available, so we'll hit equal 252. All right? So our subnet mask would be a value of 252. All right? And you could also do math this way. You can actually take all these numbers and just add them all together. I just kind of showed you the cheapskate, which is 256 minus 2 to the power of x. All right? 256 to the power of, minus 2 to the power of x. And x is how many zeros do you have remaining in your subnet mask. And this is what your subnet mask value equals. So in this case, it was 256 minus 2 to the power of 2 zeros, which is 252. All right? So this is the lowest you can get, and your IP addresses will range only 4 devices, okay? Or only 4 IP addresses, okay? So if we're starting from 0, we have 192.168.1.0. That's our network. And then 1.3 will be our broadcast. Meanwhile, IP address 2 and 1 and 2, so 192.168.1.1 and 1.2, those are going to be our 2 routers that are going to be communicating to each other back and forth. So we can say this one is 192.168.1.1. Well, this is 1.1. And we'll say this is 192.168.1.2. All right? And that's if this was being on the public side. So usually between your house, say you have a public IP address, and if you don't know how to find a public IP, just go to publicip.com. I'm not showing it because it is a confidential thing. I don't want you seeing my IP address. But if you take your IP address that's being broadcasted, that is being shown to the world, you take that and you look up you take that IP address, just subtract 1. Just imagine that's your one-to-one communication. So that's kind of your basics to an in-house network. But say you have more devices than you can fit in this network. You have more than 254 devices in your network. It's like, oh my God, I'm a big enterprise company. I have 550 devices. How do we do that? Well, your subnet masks aren't limited to always starting with 255, 255, 255. Your subnet mask can actually be changed even deeper. We can actually take this last number here, and we could take that binary bit and put it all the way over here. So we can make this subnet be turned into a /18 network. So again, it's a simple math. I'll copy this here again, Control V, paste that. And we'll say that we have a large amount of devices. All right. We have so many devices, it's just insane. 1, 2, 3, 4, 5, 6. Okay. So let's say this is our subnet mask we're chasing down, because we want to have 8, 9, 10, 11, 12, 13, 14. Let's see how many devices that is real fast. So to figure out devices, it's how many zeros you have. So let's go 2 to the power of, I said 8, 9, 10, 11, 12, 13, 14. 2 to the power of 14. So that's how many devices I need in this network right now. Okay, let's just say we have 16,384 devices in our network, and we want them all in that same subnet. Okay, what we could do is this, and we'll make our subnet mask actually turn into 192 here, and then we'll make our last digits 3 zeros. Okay, so so we're pretty much, because this is the same binary number, we're just moving it over, and then we'll turn the rest into zeros. So now all of these zeros can be assigned IP addresses. So how do we figure out our range? Well, it's a little more complex, because now instead of focusing just in the lower IP address range, you're also having to add to this 1. And it's not simple math just saying, oh, it's 155. How much was that number there? We can't just say that the IP address is going all the way up to 16384. Not the way it works, because again, IP addresses, the subnet, the bits only go up to 255. It only goes 0 to 255. So how do we figure this out? How do we figure out our range? Well, in this case, we're gonna have this 192.168 be changed to 192.168.0. Okay, so 192.168.0. This is our network address. 5.0. So this is our network address. Now I want to find my broadcast address in this big, broad network of devices that I have. So what do I have to do is I need to first consider my last bit. Well, we need to consider the sum of these bits, okay? We have to do math on these bits. So if you followed along earlier, we did the mathematical equation of did my notepad close? Notepad. So we had a mathematical equation here of 256 minus 2 to the power of x. And that's how we could find our broadcast address in this setup. So we'll do that again here. 256 minus 2 to the power of 6. All right. And I believe that came out to 64. So 64 is going to be our second to last bit in this equation. So 192.168.64. Okay. Dot. Now we have to go to the highest possible number in our last range, which is the 255 value. So that's kind of how you can go beyond the limit of your subnet mask. And this is kind of also where classless IP addresses came into play, or where class-full IP addresses came into play. So if I bring this browser over here and say class-full IP addressing, you'll have a table usually, and it shows a range. Let me see. Do we have that table hiding in here somewhere? I don't think so. Let's go back. Let's go to images here and find a class-full reference. So let me find you a good table here to sample off of. Yep, here we go. So here's kind of your explanation between class-full IP addresses. You notice that the class C range went from 192 to 223. Class D, 224 to 239. Class E, 240 to 255. What was the purpose in these is because subnetting didn't exist in the beginning, companies that needed all these IP addresses would actually have to call their ISP and say, hey, I need IP addresses for so many devices. And hence, that's why you see big corporations usually having an IP address, usually starting with 127 sometimes, or sometimes 128, instead of starting with that typical house address of 192.168. So a lot of big corporations, they had that IP address. Like if you go to your work computer right now, type in IP config, you'll usually see that your IP is 127.0.0 something. That's usually your work IP address. Sometimes you'll see some networks where it's a 10.0.0.0 something. So this kind of originated because of classless IP addresses in a way. Now, in our sample, we're using classless IP, we're using classless IP addresses, and we're able to range a broader spectrum of devices. So I think we pretty much covered the basics to your subnet mask, to your subnet calculations. You should have answers now if you were really confused in the beginning of how subnet masks work. And again, here's your equations you need to know. To calculate your total count of devices in your subnet, you would take your the number of zeros. So we have let's say we have 4 zeros. Okay. You take the number of zeros, 2 to the power of the count of zeros. All right. So 2 to the power of X, which is your count of zeros. That tells you how many possible IP addresses you can have. But to know the number of devices you can have, you have to also add a -2. All right. That is how you count. That's how you calculate your range and also the number of devices in your network. To calculate the number of possible subnets you could create, if you gave every subnetwork the same subnet mask, you have to take what is your top level subnet. Okay, so say we had this, like, again, back to this 192 situation over here, where we broke this one network into two. We would take our top level subnet, and we're going to figure out how many bits are we borrowing off of that for our subnetworks that we're creating off of that one. So if we had this 192 network up here, the 255, 192, and we wanted to do this subnetting here, the 224, we have to take that 192, and we already have 2 bits borrowed, but we're borrowing another one now. So it's honestly just 2 to the power of 1. Okay. So 2 to the power of 1 equals 2. So if we gave all the devices that 224, we have 2 separate subnetworks if we started with this one. So if our top level network is that, our new subnetwork will be that. If I borrowed 3 bits, it'd be 2 to the power of 3 in that matter. Okay. So if I borrow 3 bits, how many subnetworks am I creating? I'm able to create 2 to the power of 3, which is 8. So I could create 8 subnetworks if I added another one in here, if I was going from here to here. So that should kind of be clicking in your head on how to do that math. Next up is how we got our network address. Our network address and our broadcast address. Network address is always 0. And then for every subnet calculation, so say 64, say we're doing that 192 network, there were 64 bits borrowed, which was 2 to the power of the count of zeros. So we take 0 plus that 64, which gave us 1.64 as our second network address. Our third address, we just added another 64. Our fourth address, we added another 64. To get the broadcast address, you're taking your total, you're taking your network address and you are adding the total number of zeros. Okay, so we had 64 devices due to our 2 to the power of zeros, and we're going to subtract 1 from that value. So 2 to the power of x minus 1 will get us our broadcast. Okay, so 2 to the power of x minus 1. That's your broadcast address. I honestly feel we pretty much covered everything that I was looking to cover in this video. It's just introduction to subnetting. Hopefully you got somewhere with this. If you still have questions, feel free to leave them in the comments. Like and subscribe for more content on networking, engineering, programming, all that stuff. I'm not posting daily, but I post when I can. So like and subscribe for future updates, and I'll see you in the next video.